Hello and welcome back to this course on programming with Rust. In this video we're going to talk about testing our Rust code. And here's one of my favorite things about Rust. The test runner is built right into Cargo. So there's nothing to install, there's nothing extra to set up. We can just start writing tests straight away. So in this video we're going to learn how we can write a test, how to run it, and also how to check for both the values we expect and the errors we expect. We'll start off in a test project for our tests, no pun intended, just to get a handle on testing. And then we'll head back into the interpreter project that we built earlier and add a few tests to that. So that from here on, we can keep changing it without ever worrying that we've broken something in our code. So here's the plan. We're first going to write tests with the test attribute. Then we're going to look at assertion macros. Then we're going to learn how to test code that panics when it's meant to panic, and how to return a result straight from a test. And then to finish, we'll talk about the difference between unit tests and integration tests. So a test in Rust is just a function with a special tag on it, which is called the test attribute. Cargo will then find every function that's tagged that way and run it for you. So let's write our very first one. For these first examples, we're going to use a fresh throwaway library project. So we can spin one up with cargo new testing -- lib. And I'll cd into that, and then we'll look at the file explorer. And under source, it's created lib.rs because this is a library project. So I'll just get out the terminal for now. So this is our code, and it's actually generated a test and a function for us, which is pretty handy. But what I'm going to do, I'm going to delete all of that and we'll write something from scratch. So starting with the following. Okay, let's take a look at this code that we've just written. So up top, we have a function called triple, which is just a normal function. We're just going to take a number and then triple it. Very easy. And then below is our test. So they live inside a module marked CFG or configuration test. And this part just means only compile this when we are testing. Don't release it in the real program. Inside, we use a super : star, which pulls the code in from the rest of the file. So this gives our test the ability to see this triple function and call it. And then we've got the test itself. So in this test, we've called it triples a number. And we're going to check if that 444 really is 12. We can run the whole thing using cargo test. So I'm going to open up this terminal again, clear it, and we're going to write cargo test. It's run out one test, and our triples a number test has passed. So we get one passed. Fantastic. There we go. All right, so now let's move on to assertions. So inside a test, how do we actually check things? And we check them using assertion macros. There are three that you'll use quite often. First, there is the assert, which takes a single true or false value and fails that test if it's false. You have assert equals, which checks if two values are equals, like we're using here on line 11. And we also have assert not equals, which is the opposite, and that checks if two values are different. So let's see all three of them at once in action. And I'm going to write another function, and we're going to write the following. Okay, we'll run this using cargo test again. And there we go, both our tests are passing. So now let's take a look at both of these comparison macros. So assert equal and assert not equal. These are the ones that we will be using quite often. And the reason why is that when one of them fails, it doesn't just say why the test failed. It essentially prints both values, the one you got and the one you're expecting. So 9 times out of 10, seeing these two side by side helps you find out what went wrong in the result of your test. So these are the ones you're going to use quite often. Okay, now let's take a look at testing panics and results. So sometimes the correct behavior in our code is for it to panic, to stop and throw something that has gone wrong. And you want to test to prove that it's really going to do that. That's exactly what the should panic attribute is for. So the test only passes if the code inside it panics. So let's see this in action. All right, let's open up our terminal again. Just clear that up and test it. And there we go. So we're running our tests, panics on bad index. And our second one passes a number, and those two have passed. So just get out of the terminal and let's explain what's going on here. So the first test uses should panic, the should panic attribute there, to confirm that reaching for an index 99 on a 3-item vector is going to actually panic. And the second test shows a handy trick that I mentioned, that this test actually returns a result. It then lets us use the question mark operator right inside the test. So instead of unwrapping the task and risking a messy panic, the question mark quietly turns any error into a failed test. It keeps the body clean and it still fails loudly should something break. Before we add tests to our interpreter project, let's talk about unit tests versus integration tests. So these are two broad kinds of tests and they do slightly different jobs. So unit tests are essentially tests that we've been writing in this lesson so far. They're living right next to the code inside this configuration test module in the same file. And because they're in the same file, if we had private functions, they'd be able to reach into those. So this is quite handy. Now, integration tests would live in their own separate folder. So if I open up the file directory, essentially what I'd do, I'd create a new folder, write tests, and then I could actually create a new Rust file, integration.rs. And this is where our integration tests would actually live. Every file in this test folder would have its own little test program, and it could only use your public API, exactly like a real user of your library would. So this is a typical layout that you would use, and you've got your source code under source. This is a typical layout that you'd use for your Rust projects. So the easy way to remember it, unit tests check the little pieces from inside your Rust files, and integration tests, the idea is that it checks the whole thing works from the outside. All right, so let's apply some tests to a real project that we created earlier. So in my interpreter project, this is the interpreter project that we built a couple of episodes back. We're going to go and add some tests to it in this main.rs file. So I'm going to scroll all the way down right to the bottom because by convention, the tests are at the bottom of your Rust files. And we're going to add a test module underneath everything else that's already in this file. So the same configuration test module we've been using all episode. Inside it, we're going to check two things. We're going to check that an expression evaluates to the number that we expect and that a bad expression comes back as an error. So let's write the following. All right, I'm going to open up my terminal. I'll work in a new terminal this time. So cd into the interpreter project and type cargo test. So it's run our two tests and it's passed it. So the first test pins down our precedents that we worked on in that project. If you're not quite sure what I'm talking about, go back and check that project and see how we built our interpreter. But essentially, we're checking that 2 plus 3 times 4 has actually come out as 14, not 20. And that use superstar at the bottom of the module, so I'll just scroll down here, is what lets the tests reach into the rest of the file, call run, and then grab hash map, just like our earlier examples in our test project that we created at the start of the video. The second test confirms that dividing by 0 comes back as an error. And the payoff here is that if we ever come back, refactor this interpreter, and accidentally break something, running cargo test will tell us the moment that it happens. And there's a whole development practice called test-driven development where you actually write the test first and then write your code. So you write the tests, run them, they're all turn red, and you kind of refactor your code as those tests turn green. So you're actually testing the intended behavior. We aren't going to get into that here, but for now, we've written some tests for our project and we can see that they're passing. So if we ever were to change something in the future and then run our tests again, we can see what is breaking and what's not working and maybe change the tests to fit the new feature within our interpreter program. All right, let's recap. So in this lesson, we learned that a test is just a function with a particular tag. So we mark it with the test attribute. It lives inside a configuration module, and cargo test will find it and run it. There's nothing extra to install. It's built right into cargo. We also learned that assertion macros check the results. So you say what you expect, and macros like assert equals will compare it against what you actually got. If they don't match, the test fails and it shows you both values. We also saw other macros like assert and assert not equals, which more or less do the same thing. We also learned how to build tests or write tests that test failure on purpose. We looked at should panic, how it can make a test pass only when the code panics, so you can prove that your error cases really fire. And we also looked at tests that can return results, and we saw how question mark notation work inside those kind of tests too. And then finally, we took a look at integration tests and unit tests and how they do different jobs. We saw how unit tests sit in next to your code and check the small pieces from the inside. And we took a very brief look at how integration tests would live in their own folder and use your library in the same way that a real user would. We then applied some unit tests to our interpreter project. So all of the code that I've gone through in this lesson is going to be available on my GitHub. Check out the description below for that code alongside some key resources to help supplement the video. Hopefully you liked this video. If you did, give it a like. If you want to see more videos on Rust and other tech things, don't forget to subscribe. And any questions, please pop them in the comment section below. Next up, we're going to cover two features that will help reshape the way that we write Rust. We're going to take a look at iterators and closures. So thanks for watching this video. Hope to see you in the next one.